Now this is another question that will broaden your understanding on the first principle. Now we have on the first principle, we should find dy dx of the function y is equal to s squared. So as usual, now when y, please go, if you this is the first time you're listening, go and watch the introduction before you come here. Yes, go and watch the proof of the first principle before you come here. Now, with this one, you know our y is equal to s squared. So I'm going to say that let the y be the same as f of x, be the same as s squared. So I need to find my f of x plus h. So f of x plus h means that the x here is the same as h, is the same as s plus h. So let me put it, I'm going to get x plus what? H or whole squared, because this particular s is the same as the x here. This one and this one are the same. Now at this point, to make the thing so simple, expand this one. Now, this one you need to be able to know how to expand. Yes. How do we expand this one? To give us s squared plus 2xh plus h squared. This is binomial expansion to give us s squared plus 2sh plus h squared. Now let's solve for the numerator. We said that from the first principle, the formula is lim of f of x plus h minus f of x divided by h, where h is approaching 0. This is the formula. Now I'm going to take the numerator first. So I'm going to solve for f of x plus h minus f of x. Now what is f of x plus h? Is the whole of this one. So we have s squared plus 2sh plus h squared minus, I am subtracting f of x plus h minus f of x, so that I'm going to get the top one. And then f of x plus h is the whole of this one. That is this. Minus f of x is this. That is s squared. And when it happens like that, this s squared and this s squared will cancel. So the whole thing will left with s h plus h squared. The whole thing will left with 2xh plus h squared. Yes. Follow gradually. Now, dy from the formula dy dx, we are looking for the first derivative dy dx, which means you are differentiating this one to f of s. Now, look at this dy dx. Let me write the formula. Limit of h approaching 0 of f of x plus h minus f of x, all divided by h. Now we are still on dy dx. Now we have a limit of h approaching 0. Now you know that f of x plus h minus f of x is the whole of this one. The numerator is the whole of this one. So let me substitute. So I'm going to get 2xh plus h squared. Now all divided by the h, the denominator h. Now we can't substitute, we can't find the limit of h approaching 0, because the moment you put h here, everything will be undefined. So you have to factorize, make sure we cancel h out here. You get it? Yes, so let's factorize h out. So we have dy over dx will be equal to lim of h approaching 0. Let's factorize h out. So we're going to get h, here we're left with 2x. Here we're left with 2x. Now h will cancel one of this one, so we're going to get h. Now all divided by h. Now at this point, this h will cancel this particular h. Now let me continue from here. So we have dy over dx is equal to lim of h approaching 0 of what? H will cancel h, so 2x plus h. So we're going to get 2x plus h. Now when h is approaching 0, now this one is a linear, it's a polynomial function, it's not rational function, so we can do our direct substitution. So this one will give us what? When h is approaching 0, we do substitution. The h is 0, so the whole thing will give us what? 2x, which means our dy dx is now equal to 2x. So this is as simple as that. So when we have a curve, this one is a quadratic curve, which can give us a curve like this. This one will give us a curve like this. So when we have an x and y plane, and we have here s is equal to 2. We want to look for the corresponding value of y. So which means we are looking for the gradient of what s is equal to 2. When you put 2 inside here, because this 2 is x, when you put inside, you're going to get what 2 times 2, which is 4. And 4 will be the gradient of this particular curve at this particular point. You get it? Now watch more video to know. We have plenty of questions and this. Let's take another question.